8-6, factoring ax squared plus bx plus c. So our objective for this section is to factor trinomials of the form ax squared plus bx plus c. This is going to differ from the factoring we did last time because now there's going to be a number in front of the lead term, in front of x squared. So we can write some trinomials of the form ax squared plus bx plus c as the product of two binomials. Okay, so let's consider the trinomial 6x squared plus 23x plus 7. Okay, so what we're going to do is we're going to take that middle term, 23, because it came from two different terms in the FOIL method, two different terms added together, and we're going to think of it as 2x and 21x. So we're going to break it into two different pieces. How do we find those pieces? We'll talk about that in a minute, but we're going to break it into these two pieces. 2x and 21x is 23x. So if we rewrite the trinomial as 6x squared plus 2x plus 21x, that's our broken up 23, and then plus 7, you can see that I can now factor this with a grouping method. So in these first two terms, let's clear this off. In these first two terms, it has a common factor of 2x. These second two terms have a common factor of 7. And then the leftover bit, 3x plus 1, is the same for both. So then I could group the 2x and the 7 together as 2x plus 7 times 3x plus 1. And notice, right, if I FOIL this back together or distribute, that's 2x times both of those, 7 times both of those to get back to my original expression. So how do you know to write 23 as 2x and 21x? Notice that multiplying 21 and 2 gives you 42. So if we take the product of these two, 21 and 2, that gives us 42, which is also the product of 6 and 7. Okay. This example suggests that to factor the trinomial of the form ax squared plus bx plus c, we are going to look for the factors of the product of AC that have a sum of b. This method that we are going to use in this section is called the AC method because we're going to take the term that's in A, we're going to take the term that's in C, and we're going to multiply them together to get a number. And then we're going to find the factors of that number that add up, right, when I find the two factors of that number that add up to whatever is in the middle term, B. Let's see how this works. Okay, so what is the factored form of 5x squared plus 11x plus 2? So in order to do this method, we first find A times C. That's 5 times 2. That's 10. Okay, so now we find the factors of 10 that add to 11. So that's 1 and 10. Let's just do them both, 2 and 5. Okay, and when I add these together, right, I get 11 and 7. So my factors are going to be 1 and 10. So now, with that information, I take my trinomial, 5x squared plus 11x plus 2, and I split the middle term. So I change it to 5x squared plus 1x plus 10x plus 2. Doesn't matter what order you do them in, going to get the same answer each time. So now to factor by grouping, the grouping method, I'm going to look at my first two terms here, and I'm going to say, what do they have in common? They both have an x in common, and that's it. So I'm going to factor out the x, and I'm going to be left with 5x plus 1, right, if I divide both terms by x. Then I look at my second two terms, and I see, what do they have in common? Well, both of them have in common a 2. And what's left over? 5x plus 1. If these two terms are not the same, Unfortunately, you did this process wrong. So go back and check and see what you did. Okay. So now my answer, the two binomials that multiply together to give me the trinomial 5x squared plus 11x plus 2 is going to be this term and this term, x plus 2, this term, and 5x plus 1. Okay, so I don't write the 5x plus 1 twice, okay, because it's using the distributive method, using the distributive property, right? We're distributing the x to both of these and the 2 to both of these. I can collect these two and multiply x plus 2 times 5x plus 1. Basically, I'm kind of factoring out the 5x plus 1 from both of these two different terms. Let's try got a problem. Okay, so we have 6x squared plus 13x plus 5. So a times c is going to be 6 times 5 is 30. Okay, so now I'm going to keep listing every single factor of 30 until I find a factor pair that adds up to 13. Okay, well, 1 and 30, when I add them up, I get 31. Oh, good. 2 times 15 gives me 30. Add those together, I get 17. No good. 3 times 10 gives me 30. When I add them up, I get 13. And I could keep going, of course, but I'm not going to do this next time. 5 times 6 gives me 11. That was no good, right? We want this one, 13. Okay, so once you find the factor pair, you don't have to keep going, right? You don't have to find them all. We can stop. Okay, so let's start with my original expression, 6x squared plus 13x plus 5. I'm going to break the 13 into 3 and 10. So 6x squared plus 3x plus 10x plus 5. And now I'm going to factor by grouping each of the first two terms and each of the second two terms. In the first two terms, they have a 3x in common. So that leaves me with 2x plus 1. These two terms have a 5 in common, and that leaves me with 2x plus 1. Okay? Both of these terms are the same. That is good. That is what I want. So now I factor out the 2x plus 1 or collect the 3x plus 5 with the distributive property. Either way you want to think about it. And my answer becomes 3x plus 5 times 2x plus 1. Okay. For part B here, in ax squared plus bx plus c, suppose ac is negative. Okay. And what do you know about the factors? Oh, sorry. Suppose AC is positive and B is negative. Okay, well, if AC is positive and B is negative, that means both of these terms have to be negative. Negative 1 times a negative 30 is going to be a positive 30. And when I add them together, I would get a negative B, a negative 31. Okay, so remember that this sign, if it is positive, means both signs are the same. That sign, if it's positive, means both signs are positive. If it's negative, it means both signs are negative. Now, when AC is negative, we're going to have to think about this a little differently. When this second term is negative right here, if we remember from basic factoring, that means that the two terms, the two binomials are going to have different signs. Let's see how this works. Okay. So, first, we want A times C. A times C is going to be a negative 45. Okay. B is a positive 4. So if we have a product that is negative and a sum that is positive, that means that the bigger number, right, if one is negative and one is positive, and I add them together and I get a positive number, that means the bigger number is positive. So when I'm looking at the factors of negative 45, I could say, well, the factors of negative 45 are 1 and negative 45, or negative 1 and a positive 45. But if this bigger number, the bigger number is negative, I'm never going to get to a positive b. Okay, so I don't have to worry about looking at both of these. All I have to worry about in this case is the first number is going to be negative, the smaller number is going to be negative, the second number is going to be positive. And that depends on b. If b were a negative number, then the 45 would be negative and the 1 would be positive. But in this case, it's not even correct, right? So negative 1 plus 45 is 44. Okay, well, negative 3 times 15 is also negative 45. And when I add them together, I get 12, which is not 4. No good. All right, well, negative 5 times a positive 9 is a negative 45. And when I add them together, I get a positive 4. That is what I want. That is what I'm looking for. Okay, so that's just the first step, right? Now we need to factor the trinomial, okay? So we start with 3x squared plus 4x minus 15. I break the 4 into minus 5x and plus 9x. Okay? Still going to give me 4 when I put them back together. Okay? It's just now these are going to accomplish the thing I want to accomplish. Factor by grouping. We are going to group these two, factor out a x. That's it. 3 and 5 don't have anything else in common. Okay? So that's going to be 3x minus 5. But 9 and 15 have something in common. 3. So I'm going to factor out a 3 to give me 3x minus 5. Double check that my two parentheses are the same. They are. And so my answer is going to be x plus 3, 3x minus 5. Okay, let's try. I got a problem. Factored form of 10x plus 31 minus 14. Okay, so a times c is going to be negative 140. Okay, and we'll see this more with the next problem, but one of the biggest drawbacks to this method is that when you multiply a times c, your numbers can get pretty big pretty quick. Okay, 140 is a kind of a big number to factor. Okay, but it's okay, we can do it. There's other methods that we can use to factor this, but the AC method is kind of the most straightforward. All right, so let's do this. AC is negative. B is a positive 31. So that means that the bigger number in each case must be positive. Well, we start with 1 times negative 140. That is the bigger number must be positive. So it's negative 1 times 140, which is 139. No good. I need 31. Okay. Negative 2 times 70 is 140. That's a 68. No good. I need 31. Okay, 3 does not go into 140, but 4 does. Negative 4 times 35. And when I add those together, I get 31. Now there are, of course, more factors of 140, but who cares? We have the answer, so we can just move on. All right, so let's get to my trinomial. 10x squared plus 31x minus 14. I'm going to break that middle term into the answer that I just got when I was looking at my factors. So that's 10x squared minus 4x plus 35x minus 14. Let's factor with grouping. These two together have a factor of 2x. That gives me 5x minus 2. And the other two have a factor of 7. Common factor of 7, which is 5x minus 2. Double check. Are these two the same? They are. My answer becomes 2x plus 7 times 5x minus 2. Okay. So the area of a rectangle is 2x squared minus 3x, 13x, minus 7. What are the possibles of the dimensions of the rectangle? Use factoring. Why would we use factoring? Because the area of the rectangle is length times width. So some length and some width, when I multiply them together, are going to give me 2x squared minus 13x minus 7. Okay, well, what two things? Let's factor it. A times C is going to be negative 14. B is negative 13. That means I want the factors of negative 14 that add up to negative 13, which means the bigger number is going to be negative. So let's try the first one. And 1 times negative 14 is negative 14. 1 minus 14 is negative 13. And right there we have our answer. Okay? 2x squared minus 13x minus 7 was my original problem. I'm going to break the 13 into plus 1x minus 14x minus 7. Common factor of the first two is x, 2x plus 1. Careful here, okay? We want the middle term to be a positive here, okay? So both of these do have a negative in common. And if I factor out a negative 7, that leaves me with a positive 2x and a positive 1, right? If I were to distribute back the negative 7, negative 14, negative 7, okay? So just be careful with the signs here and realize that we can factor out a negative number in order to make both of these the same. If I had only factored out a positive 7, that would have left me with negative 2x minus 1, not the same as 2x plus 1. So my answer becomes x minus 7, 2x plus 1. Okay? Still got a problem. So the area of a rectangle is 8x squared plus 22x plus 15. So again, we are looking for A times C, which is 120, positive. Everything's positive here. That's good. And B is 22, but right, we don't have to think about the signs here because both signs are the same. Both signs are positive. Unfortunately, 120 is a big number, and you might see the answer right away already, but let's walk through each one of the factors in order to make sure that we don't miss it. Okay? So 1 times 120 is 120. Add them together, I get 121. No good. Okay? 2 times 60 is 120, and that's 62. 3 goes into 120. How do I know? Because the digits add up to 3. So 3 times 40 is 120. Add those together, you get 43. Right? No, no. Okay, keep going. 4 goes into 120 30 times. That's 34. No good. 5 goes into 120 24 times. Add them together. We're getting closer here. 29. No. 6 goes into 120. How do I know? Because both 2 and 3 do. And it goes in 20 times. And that's 26. Close, but still not 22. 7 does not go into 120, but 8 does. 8 times 15. Well, that's 23. Not close. It's close, but it has to be exact, right? We can't just be close enough. And maybe you said this right at the beginning, but 10 times 12 is 120, and when I add those together, I get 22. Right? So that right there is one of the biggest drawbacks of this method, is that it could take a while to think about all the factors of 120 and to find the pair that finally add up to 22. Okay, so 8x squared plus 22x plus 15. Remember, all that was just to get the things that are going to give me the factored answer. So now I have to actually do the factoring using 10 and 12. Okay, so I'm going to break 22 up into 10x plus 12x plus 15. 8 and 10 have a 2 in common, so that's 2x, 4x plus 5. 12 and 15 both have a 3 in common, so that's 4x plus 5 as well. That's good. They match. So my answer is 2x plus 3, 4x plus 5. And those would be the possible dimensions of the rectangle. Okay, so to factor a polynomial completely. First, factor out the GCF of the polynomial's terms. Then factor the remaining polynomial until it is written as the product of polynomials that cannot be factored further. So what does that mean? It means it has a common factor. Take out the common factor first. Make the problem easier. Like this problem right here, 18x minus 33, 18x squared minus 33x plus 12. If I jumped right into this problem, I would have to find the factors of a times c would be 216. Okay, that is not something I want to do. Okay? But maybe I can make this question a little bit easier for myself, and I can because I notice that each one of those terms is divisible by 3. Okay, so if I factor out a 3, I would get 6x squared minus 11x plus, not plus 12, plus 4. Okay, now this is much easier because now, let's do it down here. Now AC is equal to 6 times 4 is 24. Okay, B is negative 11. That means I want the factors that multiply together to give me a positive 24. When I add them together, I get negative 11, which means both terms will be negative. Okay, so let's try. Negative 1, negative 24. When I add them together, I get negative 25. Oh, negative 2 times negative 12. When I add them together, I get negative 14. Oh, okay, well, 3 goes into 24. That's negative 3 times a negative 8. Negative 3 times negative 8 is positive 24. When I add them together, I get negative 11. Good, okay? Don't lose the 3 out front. So we have 3 times 6x squared minus 11x plus 4. I'm going to break that 11x, that negative 11x, into minus 3x minus 8x plus 4. Then I am going to find the common factor between the first group. So that's going to be 3 times, common factor would be a 3x. So that leaves me with 2x minus 1. And the second set right there, their common factor is a negative 4, okay, which leaves me with 2x minus 1. By factoring out that negative, right, I can change the sign of the second term. Okay, now, finally, don't lose the 3 in the front, and now my two factors are 3x minus 4 times 2x minus 1. Okay, and then because this is all multiplication, right, I can get rid of these, right, outside parentheses like that. Okay, let's try a got it problem. Okay. What is the factored form of 8x squared minus 36 minus 20? Okay, so I could start out with the factors of 160, right? 8 times 20, negative 160. But I don't want to because I noticed that each one of these 3 is divisible by 4. So that is how I'm going to start. So 2x squared minus 9x minus 5 when I take out the 4. Now a times c is just negative 10. B is negative 9. So I want the factors of negative 10 that add up to negative 9. That means the two factors are going to have different signs. And it means the larger one is going to be negative 1 and negative 10. Well, hey, look at that. When I add them together, I get negative 9. Okay, so Don't lose the 4. 2x squared minus 9x minus 5. 2x squared. I'm going to break it into x minus 10x minus 5. Don't lose the 4. Common factor is x squared. So I'm going to pull out x squared to give me 2x plus 1. Sorry, just x. Common factor here is a minus 2. That leaves me with a positive, is a minus 5. That leaves me with a positive 2x plus 1. And then finally my answer would be x minus 5, 2x plus 1. Okay. Good. So our lesson check, factor each expression. So using the same method, we can factor all of these. Whoops. Okay, so 3 times 5. So that's the factors of 15 that add to 16. So that's going to be 15 and 1. Right? We want the factors of 20 that add up to 9. Let's look at that one. 20, B is 9, so AC is 20. B is 9, everything is positive. What's that going to be? It's going to be 4 and 5, right? So 4 times 5 is 20. When I add them together, I get 9. Let's finish this whole problem. So that's 10q squared plus 9q plus 2. I break it into 4q and 5q. And I factor out the common factor of 2, 5q, or 2q, sorry, 5q plus 2. And, it has nothing in common. Well, if I factor out nothing, right, to leave a 1 there, isn't that the same thing? And now, my factors are 2q plus 1, 5q plus 2. We always have to have this setup right here, okay? We always have to have 5q plus 2 in parentheses, and then when I factor it out of both expressions, then I need to have something left behind there, or I need to have something to put in to this first set of parentheses, okay? So if there's no common factor here, right, the common factor is 1 when I factor it out, okay? Uh, quick look at this one. Factors of 12 that subtract to 4. So AC is negative 12. B is 4. That means the bigger number must be positive. And that would be negative 2 and 6. Okay? And then use that to factor. Okay? This one, a little bit harder because we have the factors of 6 times 72, which is going to be 432. Okay, so you're going to have to step through all the factors of 432, use a calculator, okay, in order to figure out what the two factors are actually going to be. Again, that is one of the biggest downsides of this method as opposed to any other method that we would use to factor ax squared plus bx plus c, is that by multiplying the 6 and the 72 together, the numbers can get very big very fast. There's other methods, but let's stick with this one until we get a little bit of more understanding. 5, explain why you cannot factor the trinomial 2x squared plus 7x plus 10, because the factors of AC is equal to 20. B is 7. The factors of 20 are 1 and 20, 2 and 10, 4 and 5, and none of those add up to 7. Okay, so we cannot factor that. It is unfactorable. We can do stuff with it in a later time, maybe in Algebra 2. We can solve it, but we can't solve it by factoring. To factor ax squared plus bx plus 3, a student correctly rewrites the trinomial as ax squared plus px plus qx plus 3. What is the value of p times q? Well, p times q is going to be the same as ac. That's the point of this. Okay, so it is going to be 24. Okay. How is factoring a trinomial ax squared plus bx plus c when a is not equal to 1 different than factoring when a is equal to 1? Well, when a is 1, right, we can just look at this last term in order to find the factors of c that add to b. When it's not 1, we have to find the factors of ac that add up to b, okay, which does make it a little bit more challenging. And that was 8-6, factoring ax squared plus bx plus c.